Assalamu alaikum. My name is Dr. Hubar. I'm going to solve some examples of calculus. And first questions, we have a retailer of motorized bicycles had examined cost data and determine a cost function which expresses the annual cost of purchasing, owning and maintaining inventory as a function of this size, number of units of which order it places for the bicycles. The cost function is C is a function of Q, and Q is a size, and cost function is equal to 4,860 divided by Q plus 15Q plus 7,50,000, where C equals annual inventory cost stated in dollars, and Q equals the number of cycles or each time the retailer replenishes the supply. So now we have to compute, determine the order size which minimize annual inventory cost. Second part is what is the minimum annual inventory cost expected to equal. So guys, from this question you understand how to solve this problem. And okay, I'm giving you clue. Just think about it in 1 minute and tell me, have you learned it relative maxima or minima? I think this problem is like we can solve this matter, maxima or minima. Right? So now actually we come to the question again, determine the order size which minimize annual inventory cost. So we're going to calculate order size, means Q, and that Q where we find value of function is minimum. So we have f of Q is 4,860 divided by Q plus 15Q plus 750,000. If we take derivative and then it compare with 0, so we find Q, value of Q. That Q is where we find function of at this point will be minimum. So now going to compute. So first derivative is 1 over Q is minus Q power minus 2, and 15Q derivative of Q is 1, so 15 times 1 is 15, and now I'm equating with 0, and then we're going to solve and further. So minus 4,860 Q power minus 2 plus 15 is 0, minus 4,860 Q power minus 2. We take 15 from left side to right side, and sign will be changed from positive to negative, and this negative to this negative will cancel because both signs are same and two different sides. And now 4860 is multiplied in left side, and we changing the size, and then we change the sign like from multiplication to division, 15 by 4860, and then we solve and a Q power minus 2, right? So we change both sides, numerator to denominator, denominator to numerator. So we have now Q square is 4860 divided by 15. Q square is 324, and we're taking derivative. Q is equal to 18. So we won't consider negative sign, just only positive, because order size cannot be negative. So now it is the first part, we have done it, and the second part is what is the minimum annual inventory cost. So we can check it even if we this value Q is 18. If we take derivative of the same function and then plug in 18, and then you find greater than 0. This means function, the graph of f is everywhere concave upwards. Annual inventory cost will be minimized when 18 bicycles are ordered each time the retailer replenishes the supply. And for second part, what is the minimum annual inventory cost? So just we plug in this value of Q in function, and then we found f of 18 is 750540. This is the required answer. So now we're going to move in second question for the day. So our hospital blood bank is conducting a blood drive to replenish its inventory of blood. The hospital estimates that blood will be donated at a rate of DT pints per day. Pins is like a unit of volume, and we denoting symbol dt is as a hospital, estimating the blood, donation. T is a time, so we have function dt is equal to 500 times exponentially minus in a power minus 0.40. So a hospital collecting the blood with respect to time. This is a function, and t equals the length of the blood drive in days. If the goal of the blood drive in is 1,000 pence, when will the hospital reach its goal? So our question is, hospital, target, is a collection of blood is which is amounted 1,000 pence, right? So when will the hospital reaches this goal and collected the 1,000 pence? In this problem, the area between the graph of D and the T axis represents the total donations of blood in pence, right? So the hospital will reach its goal when? We have solved area under the curve, and we're going to calculate time, where when we completed, our aim, the hospital completed their aim, is a collection of blood amounted to 1,000 pence, and okay, we compare and this amount of area which is equal to 1,000 pence, right? So we take out 500 from integration side and take out outside, and then we cancel each other, right? 500 and 1,000, right? 5 times 2 is 1,000. And again, I'm not solving integration right. Still, just keep remaining. It's exponential power minus 0.4 t dt. This is a total integration, right? And its total area is now equal to 2. And then now going to integrate of function e power minus 0.4 t is e power minus 0.4 t divided by derivative of e power is minus 0.4 t. Derivative of minus 0.4 t is minus 0.4. So here is derivative. How to calculate derivative? Integration of exponential. Exponential same f of x divided by derivative of function. For exponential function I'm talking. Other function has different techniques to solve its integration. So anyway, so divided by minus 0.4, and then we take outside from the borrow sides. This is lower limit 0, upper limit t static. Just I'm denoting t static is that time hospital will collect 1,000 pence. So let's see. Minus 0.4 we multiply, and left side is divided, and right side if we take right side, then the sign will change from division to multiplication. To multiply minus 0.4, and then we get 0.8 minus 0.8, and then now I'm applying limits, upper limit minus lower limit. Upper limit is t static e power minus 0.4 t static minus you can write any symbol t static any. But I'm denoting t static as a time where we collect 1,000 pence. Pence again I'm saying is a volume of blood. Anyway, upper limit is t static. Just we substitute t is equal to t static minus lower limit 0 e power minus 0.4 times 0 is e power 0 is equal to minus 0.8 e power minus 0.4 t static minus e power 0 is 1. So this minus 1 here, and we take from left side to right side, we change the sign, we change the size, to minus 0.8 plus 1, and then which is equal to 0.2. Now I'm going to NT of exponential is log. So I'm taking the natural log of both sides of the equation, so we get minus 0.4, T static is equal to natural log of 0.2 is minus 1.6094. You can find from the table, or otherwise you check on calculator. T static is equal to minus 1.6094 divided by minus 0.4. Both signs will be cancelled, minus minus, and T static is equal to 4.0235 is actually is T static is equal to 4 days. Thus the hospital will reach its goal in approximately in 4 days. So thank you for watching. Please subscribe my channel for next video. Please share with your friends, your colleagues. Thank you. Bye bye.